Solve for when the population increases the fastest in the logistic growth equation. Logistic, that's growth, exponential growth that reaches a maximum called a carrying capacity. Here, let me do this better. So, you have, and then this is called K, the carrying capacity. It grows, because real life populations have a maximum. Like you put a bunch of deer out in the forest. Well, they grow and grow, or even rabbits have more and more rabbits. But eventually, the population, there's just so much room, so much food. There's predators. They're going to be limited. They start getting too many rabbits. There's not enough food. They're going to die off, or not enough space, and they're going to die off. So there's a K, a carrying capacity, a limit. So let me grab the equation. Here's the notes. Grab this equation, bring it down. dp dt is rp. So it says dp dt is rp 1 minus p over k. This is the carrying capacity. So you see how we can see right here. So this is the r, and this must be the k. This is the k right here. The k is 4,000. That's the carrying capacity. So that's up here at 4,000. That means 4,000 rabbits or whatever this population is the most that this environment can handle. If the rabbits somehow shoot above 4,000, they're going to start coming back down and dying off, and it's going to come down, level off at 4,000. That's what's going to happen. So anyway, it says solve for when the population increases the fastest. So when's it going to be growing the fastest? Well, you can see right here in the notes, maximum growth rate of the population occurs when the population is exactly half its carrying capacity, half K. So if K is 4,000, then 2,000, which is exactly half. When the population is 2,000, right here in the middle at 2,000, that's when it's going to be growing the fastest. And as it gets closer up here to 4,000, 2,000 is the maximum growth, it's going to slow down, slow down, slow down, slow down, because it's close to as much as it can hold. Now, so that's the end. You can just look in the notes to half K. It's whatever the carrying capacity is. The carrying capacity is whatever's underneath P. When you got a 1 here in the logistic growth equation. Now I can show you why that is. This is the P prime. That's the dP dt. It's how fast the population is growing. So the question is, when is that? Call that a function f. We're done. The answer is 2000, but I want to show you why. I can prove it to you a little bit more mathematically if you're interested. So the rest of this video is just for fun. We've already got our answer. That's all you got to do. Sorry, I'm getting really scribbly here. Okay, so all you really have to do, this is a 9, not a P there, is look at that, say, oh, right there, that's the carrying capacity and maximum. It grows the fastest when it's at half of its max, half of its carrying capacity, so 2,000. But how do they come up with it? How do they know that? Well, if this is the function for the growth, when, question being asked us, when is this max, right? Max growth. That's what they said. Fastest growth. When is this? This is the growth. This is the dp/dt, the function. When is that max? Well, how do you find the maximum of anything? What have we learned in calculus about finding the maximum? You take the derivative and set it equal to 0 and solve. That's how you find the max, right? Because it's where the derivative is 0, right? For any function at the top, at the max, the slope, which is the derivative, will be flat. Slope will be flat at a maximum. So we take, okay, f prime. How do you take derivatives? Well, first off, actually, we should get f cleaned up. Let's just, this is still f. Let's distribute through. Get 0.9 p times 1, and then minus, and then 0.9 over 4,000 p squared. I took that 0.9 p and I went boom, boom. Okay, now let's take the derivative. So now I want f prime. So derivative, let's write derivative. That's going to be 0.9 because the 1 power comes down, subtract 1, it's gone. Minus the 2 power comes down, zero point 0.9 times 2, 4,000 p to the first. And what are we going to do with that? We're going to set it equal to 0 because that's what you do, right? That's how you find where anything is maximum. You take sorry, I'm hitting the wrong buttons. Take the derivative and set it equal to 0. So, okay, here it is. Took the derivative, set it equal to 0. Now you got to solve that for p. How to do that? We'll grab this 0.9, or no, here, let's just jump this over. So we get 0.9 is positive 0.9 times 2, 4,000 p. And last step, multiply by the upside down to get P alone, 4,000 over zero point 0.9 times 2, zero point 0.9 times 2. 4,000 P is alone, we do to one side, do to the other. 4,000 over zero point 0.9 times 2, zero point 0.9, zero point 0.9, that's over 1. Look at that, it's 4,000 over 2. It's half. It's 2,000. So that proves it. That indeed it's at half the total carrying capacity, the total population can handle, where the derivative is going to be derivative is going to be equal to zero, which means maximum growth. So anyway, you don't need to do all that. You just got to have the notes at a half carrying capacity. Carrying capacity is a number under P in the formula. 4,000, half of that, 2,000, maximum growth. And so there we go.